Okay. How about, can you tune fuzzers so that they will find more zero-day vulnerabilities? Did you understand the question?
I think so. So I think the difference is really between mutation fuzzers and model-based fuzzers. So when you have a model-based fuzzer, it doesn't necessarily care about all the past mistakes at all. So potentially and most often, every single discovery that you do is a zero-day weakness, and it's not related to any past weaknesses at all. But if you do mutation fuzzer and only around known vulnerabilities, then you are not very likely to find any zero days. You are just often finding regression flows where a weakness emerged several years ago, and then the same code branch came back to the major branch, and basically the same vulnerability or a variant of that vulnerability just came back to the code, and you will refine those old weaknesses again. So you cannot really tune a fuzzer for any of those approaches, but the result of fuzzing depends completely on the techniques that you use. Random fuzzers cannot find very complex flows. Template-based fuzzers often find only weaknesses in those use cases that you have, and if they are known vulnerabilities, then you only find known vulnerabilities. And then if you use full specification-based fuzzer, then most probably everything you find is a zero-day actually.
Okay. How about keeping IPS systems up to date? So I can, like, using Codenomic and fuzzers, I can add my own rules, or how was that?
You cannot directly export rules from any fuzzer because many of the IDS systems have completely proprietary definition languages for the IDS fingerprints and the rules. So there is unfortunately still no unified language for defining those. If there would be, it would be quite practical actually to export those rules directly. But what often happens is that, especially if you use model-based fuzzers, whether they are template-based or specification-based, but if you use model-based fuzzers, you will get a test case description which explains that this message in a protocol sequence containing this header element, containing this data value will crash the product. So the test case descriptions are so self-documented already that it's just a matter of minutes to write that rule yourself. Or many of the IDS, IPS vendors are more than happy to do those for you because that's in their interest in protecting other customers as well. Or any security consultants or even companies, fuzzing companies like us can help you in building those rules as well. But really, there's no big challenge, or it's very easy to write those yourself. So for example, I used Snort for the first time yesterday, and I had no challenges in looking at those rules and actually building new ones. So they are rather easy to actually build yourself even.
Okay, and what about fuzzing around patches? Are there ready test cases for that, or do I need to modify defense test cases in order to do that?
Testing around patches. So for example, if you subscribe to vulnerability feed like Secunia, or if you receive vendor advisories on weaknesses, they often explain what protocol element and what message had the weakness. So in a model-based, specification-based fuzzer, what you actually would do is just write that test description into the tool and it will test around that. With a template-based fuzzer, you would actually load those proof of concept PCAP files from the security feed and then automatically test around that. So both of those are extremely easy and straightforward things to do. If you have the fuzzing tools, you can very easily test around known vulnerabilities. But there is no like ready-made map of known vulnerabilities in at least Codenomicon fuzzers. And the reason for that is that the number of known vulnerabilities is really growing exponentially, and providing that to every single product out there would just be unpractical, or at least it would give a false sense of security, because anyways it wouldn't test around all security problems. So it's much more proactive, not looking at those weaknesses that might actually touch you, and then test around those using the techniques that I explained. Or, for example, contacting us and saying that I need to reproduce this, and in a minute you will probably have an answer saying how you can do it potentially. And all the vulnerability data feeds are very reactive as well. So when there's a new weakness, they almost immediately have enough details of those weaknesses so that you can easily reproduce those.